Alright, hello, this is Scholar Strive doing some math today in geometry, section 1.5. We're going to describe angle pair relationships. So complementary angles. Complementary angles are two angles that add up to 90 degrees. So let's say we have angle 1 here and angle 2. Measure of angle 1 plus measure of angle 2 is 90 degrees. Let's say measure of angle 1 is 30. Measure of angle 2 is 60 degrees. So it's very important that you remember these vocabulary, because in your homework they're going to tell you that these two angles are complementary, and that means they add up to 90. Or they're going to tell you that these angles are supplementary. Supplementary means they add up to 180 degrees. So, an example. Remember, 180 degrees is a straight line. And let's have two angles here. Let's call this angle 3 and angle 4. Measure of angle 3 plus measure of angle 4 equals 180. They're considered a linear pair if they're like this picture. They're attached to each other, forming a straight line. If they're separate, so if I have this and then I have this, these are not considered a linear pair, but they can still be supplementary. So a linear pair means they're next to each other. The angles are directly next to each other and they form a straight angle if you add them together. They're just supplementary if they add up to 180. Alright, vertical angles. So vertical angles, you want to think of an intersection, basically. The sides form opposite rays, so they're going in different directions. And you have an intersection, and angles, so let me call this 1, 2, 3, 4. Angles on the opposite side are called vertical angles. And what's special about them is that they're congruent. Angle 1 is congruent to angle 4. And angle 3 is congruent to angle 2. Okay? So, let's do some examples. Measure of angle 1 is a complement of measure of angle 2. So if measure of angle 2 is 57 degrees, what is measure of angle 1? So complement means they add up to 90 degrees. So I'm going to take measure of angle 1 plus measure of angle 2 equals 90. So we know that measure of angle 2 is 57. So measure of angle 1 plus 57 equals 90. Subtract 57 from both sides, and I'll get measure of angle 1 is 33 degrees. Here we go. This time we're doing supplement. Supplement is 180 degrees. Measure of angle 3 plus measure of angle 4 is 180. So since measure of angle 4 is 41, measure of angle 3 plus 41 equals 180. Subtract 41 from both sides, and we'll get measure of angle 3 is 139 degrees. Example 3. A basketball pole forms a linear pair of angles with the ground. So they're saying angle 1 here plus angle 2 is supplementary. It means they add up to 180 degrees. So write an equation to solve for x and write a reason for each step. We're going to skip the write a reason for each step until chapter 2. Then find the measure of angle BCA and angle ACD. BCA. So 3x, so two angles added together equals 180. So I have 3x plus 8 for my first angle, plus my second angle, 4x minus 3. And that equals 180. So I have 7x plus 5. That's adding my like terms. 7x equals 175. Does this go evenly? Yes, it does. X, so if I divide both sides by 7, I will get x equals 25. Okay, now I know what x is. I'm now going to plug it into here. And there. So 3 times 25 plus 8 is our measure of angle BCA. So we get 75 plus 8, which is 83 degrees. Okay. And then over here, measure of angle ACD, or angle 2, is equal to 4 times 25 minus 3. 4 quarters is 100, or $1, minus 3 cents is 97 degrees. Okay, let's move on. Example 4. Two angles form a linear pair. The measure of one angle is 5 times the measure of the other. Find the measure of each angle. So two angles form a linear pair. So it looks like this. 1 plus 2. The measure of one angle is 5 times the measure of the other angle. So that means one angle, let's call it x, and the other is 5 times bigger. So, and then they add up to 180 degrees because it's a linear pair. They add up to a straight line. So here's angle 1, or in this case it's angle 2. If we take a look at this picture here. Here, I'll just redraw the picture. Angle 1, we call that x. And then angle 2 is 5 times bigger, so we call it 5x. So we get 6x equals 180. So x equals 30. Now I can plug it back into the original equation. So measure of angle 1 is 30. Measure of angle 2 is 30 times 5, which is 150. And to make sure that you're correct, 30 plus 150 does indeed equal 180. Alright, in the diagram, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So adjacent angles are angles that are next to each other. They're kind of like linear pairs. So they're just angles that are next to each other. So angle 1 and angle 2 from the previous example are considered adjacent, but they're also a linear pair because they add up to 180. So, for example, adjacent angles in this picture is 50 and 140. So adjacent angle DEF. So remember, the middle letter has to be the vertex, and angle FEG. Now you could have done these backwards, FED and GEF. That would have worked. Okay, now we want a pair of supplementary angles. So remember, just two angles that add up to 180. So angle FEG, that's 140, and angle ABC, that's 40. They add up to 180. And then lastly, complementary, those add up to 90. So that would be angles DEF and ABC, because they add up to 90 degrees. All right, identify all of the linear pairs and all the vertical angles. So linear pair. So linear pair are two angles that add up to 180, and there is no linear pairs in this picture. I can add three angles and make 180. That would be 1, 2, and 3, or 4, 5, and 6, or 4, 3, and 2, or 1, 5, and 6. But there's no combination of just two. So there's no linear pairs. But we do have a ton of vertical angles. We have angle 2 and 5. So we have an intersection here, and then opposite of the intersection is our vertical angles. 3 and 6. So notice how I'm always writing the angle symbol. You have to as well. That way I know what you're talking about. Now in the context of the problem, you could get away with just saying, 2 and 5, 3 and 6, 4 and 1, but I need you to practice writing in angles. Oh, and then the last, or not the last one, angle BCA and angle DCA are a linear pair. If the measure of, I'm gonna have to rewrite this one. So they say the measure of angle BCA is equal to 5x plus 1 degree. And they said that they are a linear pair, so they add up to 180. So 6x plus 3 plus 5x plus 1 equals 180. Add our like terms. 6 apples plus 5 apples is 11 apples. 3 plus 1 is 4 equals 180. 11 apples equals 176. Divide by 11 and we get 16. And then they want us to find the measure of angle BCA and DCA. We plug this back into our equation. So BCA, I'll do it over here, 5 times x, which is 16, plus 1. 5 times 16 is 80. Plus 1 is 81. And then DCA is 6 times 16 plus 3. And that would be 96 plus 3, which is 99 degrees. All right. Checkpoint 4. It's weird. Two angles are complementary. The measure of angle of one angle is 4 times the measure of the other. So complementary means 90 degrees. We have x and 4x. So 90 right here. 5x equals 90. Divide by 5 and get x equals 18. So we have 18 degrees and 4 times 18, which is 72. All right, concept summary. All points shown. So there's some things you can conclude from a diagram and some you cannot. So for example, here's some things that you can conclude from the diagram. All points shown. So you can assume that the dots are points. So A, B, C, D, and E. And even though B doesn't have a point, you can assume that's the intersection there. So A, B, and C are collinear, so you can assume things are on the same line if it looks that way. And B is between A and C. So these are things that you can assume. Line AC, line BD, and BE intersect. So you can assume that they intersect at B. DBE and EBC are adjacent angles. So just to look here, that's angles 1 and 2 here. They're adjacent angles. They're angles that are next to each other. And you can assume that they are by the picture. Angle ABC is a straight angle. So you could assume straight angles. You can assume that that is a straight line. Point E lies in the interior of angle DBC. So in the diagram, you cannot assume, so in the diagram above, so they're talking about the top one, the one that's like barely gone. Here you go. You cannot assume that this segment AB is congruent to BC. You would need the tick mark there that they show in the bottom picture. You cannot say that this angle is congruent to this angle. You would need the symbology here, like they do in the bottom. Oops. See this arc and that arc. It says that those two angles are congruent. You cannot assume right angles. I need that little box there. Alright. And that is it for section 1.5. Have a good day.